and welcome to lesson 6.1, periodic functions. So this is the introduction to our last unit, our second last unit, which is called sinusoidal functions. Okay, so to introduce this, we're going to be looking at some types of patterning that either repeat or have some symmetry to it. So just to explain or just get us starting thinking about looking at some waves or at like some repeating functions, we're going to take a look at this warm-up. So just watch and pretend you guys are on this Ferris wheel. So taking a look, ladies and gentlemen, it says we're on a Ferris wheel. Here we go. We're just getting on. Okay, it says draw a graph of a person who rides 2 rotations on a Ferris wheel that is 10 meters in diameter. So that's 10 meters. Okay, and so what does that mean? That means that the radius itself is 5 meters, if you wanted to discover that. Okay, and assume that when you start, seated at the bottom, that your head is 2 meters. So if we're 2 meters here, and we got a 10 meter diameter at the top, we're going to be at 12 meters. And halfway through, ladies and gentlemen, we are going to be 2 plus 5, because that's the radius, so we're going to be at 7 meters, both on the way up and on the way back down. So in theory, ladies and gentlemen, we're going to be going this way, which is counterclockwise. And we are going to start at 2 meters. So the trend that we're looking at here is we start at 2 meters, then we travel to 7 meters. Okay? Then we get to 12 meters. Then we start coming back down 7 meters. Then we're at 2 meters again and go for it. So that's one complete rotation, but we're going to keep going. So we're going to go 7 meters again, back up to 12 meters, back down to 7 meters, and finally we're going to end at 2 meters. Okay? Just envision yourself on that Ferris wheel ride. So what we're going to do is realize that there's some repeating values, which is going to show some patterning. All right, so if I graph this data, taking a look here, I've got rotation, so a quarter of the way around. This is half, which means I'm at the top. Okay, when I'm 1 rotation down, I'm back at the bottom. Okay, when I'm 6/4, I'm back at my top on the second time. And when I've completed 2 complete rotations, I'm at the bottom, because that's where you get off, right? Okay, so let's graph this, ladies and gentlemen. At where I start, which is at the bottom, at 2 meters, quarter of the way through, ladies and gentlemen, I'm at 7. At the top, ladies and gentlemen, I get my maximum height of 12 meters. Then I come back to 7 meters on my way back down towards the bottom, and the bottom I get is 2 meters. Then I head back up again, going to hit my maximum again, come back down halfway, and then I get off at my minimum. So what you notice, ladies and gentlemen, is this is a smooth curve as you go down and up and down and up. Okay? In the future, we will see where this trend continues, and you will keep going, because you'll learn that some of these patterns repeat. Okay? Just pretend that you were going, 8 or 9 rotations around on the Ferris wheel. And that pattern would continue going back up to a maximum, back down to a minimum. All right? So what do we notice about this pattern? Well, first of all, we notice that it repeats itself. Okay? We also know that there's some symmetry about it. Okay, so now we're going to get introduced into what we call a periodic function and different parts of a function. Okay, so I'm going to flip over to the next page. So today's title is 6.1 periodic functions, and this is where I want you to write down. So instead of just watching, this is where you're going to participate here. A periodic function produces a graph that has regular repeating pattern over a constant interval. Okay. So we notice how we saw a repeat. 1 revolution was the one time that it went up and then back down, and then if we kept doing a second revolution, it went up and back down again if we looked at the previous example. All right, let's look at some terminology. And I've just copied and pasted this from your textbook, ladies and gentlemen, so it's in your text if you're reading. And the terminology we want to look at here is the cycle. Okay, so the cycle
of the periodic function is the part of the graph that repeats. So it's just a piece of the graph. So it's what's in red. Okay? Whereas the period, ladies and gentlemen, and this is where people tend to get confused, the period of the function is the change in x during one cycle. So that's the number. So how long did it take? Okay, for one cycle. So if we take a look at our previous example, it took us one rotation. So from example number 1, it was one rotation. Okay. Sometimes you're going to say how long. It's going to be a measure of time. Sometimes you're going to see it's going to be a measure of degrees, because we're going to be working with sinusoidal functions coming up. So we'll be working with degrees as well. All right. Another thing we want to take a look at is different parts of the wave. Okay. The peak is the maximum point. So right here would be your peak, or what we would call the maximum point. Okay, and the trough is what we call the minimum point. And if you take physics, you'll be using peak and trough to explain different wavelengths when you're dealing with light and wavelength motions. Okay, so trough is your minimum. All right. And what I want you to notice, ladies and gentlemen, is that when you've got a max and a minimum, you can see that there's something halfway in between the max and the minimum. And that's what we call the equation of the axis. Okay, so the equation of the axis can be found by taking the max, adding the min, and dividing by 2. Just think back in quadratics, guys, to find the axis of symmetry, you just added 2 zeros and divided by 2. Just think the axis in this case is on the other axis. So just imagine, guys, this being my axis right here. Okay, and I have a wave-like motion. Okay. Okay, so in my wave-like motion, I'm going to have a maximum, which is up here. And those are both maxes, by the way. Okay, I'm going to have a minimum down here at either one of these. Okay, and you're going to notice that the axis is halfway between it, so it kind of creates some symmetry. So you might want to write down that although this is the equation of finding your axis, okay, you're going to know that this is halfway between the max and the min. All right, so halfway between the max and the min. Another piece of terminology we need to learn, which is called the amplitude. Okay, the amplitude is the vertical distance from the axes to either the min or the max. So it's going to be the same, so it's either going to be this distance here to the min or this distance to the max. Because it's a symmetrical wave, they will be the same values. Okay, and the way to find the amplitude, there's two ways, but the way I like to write down is you take your maximum value and subtract your axis. You could also take your axis and subtract your minimum, but usually you're subtracting a negative value, so it's usually easier to do that one. Okay, there's a video here, ladies and gentlemen. That's going to be part of the second part. Videos don't work well when I'm doing my, as I've learned in the past, because I'm doing this video over again because it didn't work. So I'm going to post that as second part. So this will be part 2 of today's lesson. Okay, and it'll just be that video link. I'll throw it in, okay, on the website. All right, example 1. Determine the range, period, equation of axis, and amplitude of the function. So here's a different example of a Ferris wheel. Okay, it's not the exact same. All right, looking at this, ladies and gentlemen, the first thing I'm going to do is I'm going to look for my maximum value. So my maximum value here, guys, is, hopefully you see it's equals 13. Okay, I'm going to look at my minimum value, and I'm going to have a minimum value of 1. Okay, so it equals 1. All right, so if I know my min and I know my max, I can get my axis. So axis equals max plus min divided by 2. Okay, so plugging that in, my max is 13 plus 1, which is my minimum, divide by 2. So the axis is going to equal 7. Okay, and you're going to say y equals 7. All right, once we've got our axis, we can then find what's called, so we can draw in our axis here. If you haven't been able to see it, we've got the axis, and once we've got our axis in here, notice it's at 7, so that's where we get that from. Then we can find our amplitude. So to find our amplitude, remember that equals the max subtracted your axis. Okay, so your max is 13, subtract your axis, which is 7, so that's going to equal 6 meters. All right, now taking a look at the period, ladies and gentlemen, it's the time to complete one cycle. Okay, so it's the time it takes to complete one cycle. So you could argue that, hey, from my max to my max, I started at 10 seconds, I ended up at 50, so that's going to equal 40 seconds. Or you could go, ladies and gentlemen, minimum to minimum. So 70 subtract 30 is 40. Or you could go from the start on the axis to where it ends on the axis. It's up to you, as long as you use the same starting point where you see it repeating again. So the period is 40 seconds. All right, now the last one we need to do is the range. The range, ladies and gentlemen, has to deal with what our minimum and our maximum is. Okay, so range is y belongs to a set of real numbers such that minimum has to be less than or equal to y, which has to be less than or equal to its maximum. Okay, so we already found our minimum, already found our maximum, so we can sub those in. So y belongs to a set of real numbers such that my minimum is 1, so 1 has to be less than or equal to y, which has to be less than or equal to our maximum, which is 13. All right. You may also notice that in this example, folks, the y equals the height, so you could use it. You could also see it written in your textbook as height belongs to a set of real numbers such that 1 is less than or equal to the height less than or equal to 13. But I'll accept either, ladies and gentlemen, y or height. Make sure that looks like an h. Okay? All right. So, ladies and gentlemen, here ends our lesson for today. I just want to make sure that you go and read that video, which is going to be the second part. Okay? And here's your homework. So your homework is page 352, numbers 1, 2, 4 to 10, and give 11 a try. It's a hard one. That's why it started. All right. Have a great day, folks. And there's an introduction to the new unit. If you need some help, by all means, come and see me. Have a great day.